Okay, so now let's talk about the .NET obfuscation tricks, so that we are aware of what we are facing. So the first known one is control flow obfuscation. Control flow obfuscation basically allows the malware authors to delay your analysis. Basically means that you will go through different steps just for do a single thing. For example, here, case 0, it goes to, in this switch case 0 goes to IL7A, which is just a label which do something. In case 1, for example, you do a num2, num3, then it sets num3 num equal 3, sorry, which is gonna get out of the switch and then goes to num3. Num3 is here, which is gonna do some calculations on num4, num5, num6, and num7, and then it's gonna say num now is equal 10. Then it's gonna get out of the switch, go to 10. You can see case 4 and 5 and 6 has nothing to do. So basically here, guys, if you step into those, you're gonna realize eventually that you are stepping into so many instructions, dozens, even thousands, and you are not getting anywhere. You might get after 4, 6, 7 hours, but probably is not doable. So this kind of obfuscation, when you see it, it's important to take another approach, which we're going to see in the lab, where we can put breakpoints and move forward without spending time on this, where is this obfuscation code that the malware author wants you to stay. Here is another trick, which is obfuscating the classes, names, methods, and parameters. You can see that this specific method VFI, DQ, whatever, is a random name. Same for the second method, NYG, D3. Those are randomly generated. Actually, those are created by builders. They create these many different names, so you don't need to worry about those. And you can see that the parameters being received has these variables, which doesn't make any sense. This kind of a Unicode 0020, all of them are the same, so it doesn't give you any hint on what's going on, what is the class name here, what is the value. So you need to step into it to identify it. So it's hard to follow. Actually, here you can see the load. You remember the load. So here might be the load because they really want to obfuscate when this assembly.load is being called. This might be the case, maybe not. But my point here is that by doing this, the malware authors are gonna kind of put it harder for you to understand the flow. Junk code, junk code basically means that these guys will put, for example, here they have this method which do nothing. Then they have this method that does nothing, so what's going to happen is that when you are stepping into those functions, you will just stepping in, there is nothing to do stepping out. And this is hundreds of time in the code, and you're just basically wasting your time and again to delay your analysis. Now let's come into reflection. Reflection is a feature for those kind of virtual machine based programming languages like .NET, with the CLR, which is like a virtual machine, and like Java, has a virtual machine. So those always use reflection because they can interpret at runtime the code. It's not like a C code that you compile and you have three functions and then you just call those 3 functions. That's it, right? You cannot do anything. But with reflection, you can at runtime say, hey, give me one blob, which is bytes. Those bytes I load it in memory, get methods, get classes, their methods, their parameters, and just execute at runtime. That's why it's pretty powerful and useful. So, as I said, reflection allows to obtain information at runtime about the loaded or to be loaded assembly. You can list the classes that it has, the method names, parameter types, and you can do what is called in-memory loading of the new assembly and execution of its methods. That's why it's a great feature to load second stage malware. Like the malware can come embedded in the resources section, downloaded from internet, loaded from disk locally, and once you load it, whatever is the source, you just execute it, which is fantastic. Now, how this works? Let's see the steps. Step number 1. So first you load the assembly in memory. When you load assembly in memory, you can use different, classes and methods. For example, here you can have assembly.load, assembly.load file, app domain, current domain.load. So those are just examples, guys. And here is where it comes the cat and mouse game. Because the malware authors, they want to really hide those calls, because now that you know them, you will just probably try to put a breakpoint in assembly.load so that when it breaks, the breakpoint breaks there, you already have the object, which can be the binary, and you just dump it from memory. But if the malware authors obfuscate it, it's hard for you to find it, right? That's basically the idea. Or the malware authors is gonna find tomorrow a way to load it without putting the string. They can call, as we're gonna see in our lab, they can call load in an obfuscated way so that when you search for assembly.load, you don't find it. But eventually via reflection, they will call the method load, which is, decoded in memory, and then you need to really debug the program in order to identify what is the load being called. Once you load it in memory, then you get the class to call. For that, you can use the get type. Type in the context of .NET is like a class, basically. Or get types, which you get all the classes. Get the method to call, by get method, or enumerate all the methods in that class via get methods. Allows to get calling convention, parameter types, if it is a string, integer, long, or those things. Once you get the method, you can now create an instance of the type, the class, via create instance. And then once you have the instance, you can call the method via invoke member. It's not the only way, invoke member is one, but then before invoke member, you can even call late binding. We're gonna see it in the lab. So, there are different ways to hide these guys. But now that you see this, the next time that you're doing an analysis on .NET and you see an assembly.load, you will know that you're close to finding the malware loaded in memory, right? And then you will start trying to find the get type, the get method, create instance, invoke member, right? So that's the full idea. Okay, guys. So as I said, it's very important for us to, once we understand how to do the malware analysis manually, we need to automate it in order to be scalable. For .NET, there are many ways, and pretty cool. We can use PowerShell. With PowerShell, we can basically call via reflection, which is exactly the way the malware does. We can also use reflection in our advantage, and then, for example, call a assembly loaded in memory and just call a specific class and method and execute it. So let's say that there is a class that stores the malware on disk. We just execute that class, that method, and then the malware is gonna just load it for us on disk. Okay, so and the steps here, you can see them, right? It's exactly the same. We get the load. You get the load me in the malware, read all bytes to get all the bytes, then load those bytes via load, get the modules to get the class, get the method via the token. You remember this in the Windows binary. The 06 is the metadata token table that is related to methods. So we are seeing here, give me in the class 1 the method with this token ID, which is the first method, 02 is the second method, and so on, and then invoke it with this argument, which is hackdef here, and we can see in the response the hello from the DLL with the argument that we sent it. Another option, which is similar but in C#, is to do it, in Visual Studio. This is also pretty cool because then here you can escalate it. You can basically do something more advanced. It's not only just loading it, but you may put something more robust. So exactly the same example, you can do a load file, in this case to load it from the disk. You get the get type to get the class name, create instance of that object, get the arguments with the hackedef here, and then you invoke the member method name here, the object which has the instance, which has been instantiated, and the arguments. It's exactly the same. And then WinDBG scripting. If you have done bash scripting, you always in bash scripting you put every command that you put in the command line, you just copy paste it and put it in a bash script. And when you run it, it will just execute all those commands in the sequence you specify. Well, in WinDBG it's exactly the same. You just put the commands that you execute in the debugger, the GUI. But here, this script, you pass it to the Windows command line debugger, which is called cvd.exe. And cdb. And then it's gonna parse this script, and that's it. It's gonna run it. Okay, and here just quickly for you to see. We're gonna see this in the lab, but it's calling SXC, which is basically saying stop execution when you see the clrgit DLL loaded. Then we load the extension here, source extension for the framework 4.0. Then we put a manage breakpoint on the system reflection assembly.load because we know it's going to be called by the malware. When it hits with go, we let it go. When it hits, we store the ECX value because we know that ECX points to the object in memory, which is actually the object that contains the binary to be loaded, to be dumped. We print it here, and then we just print the content of that object. Then we know that this T0, which is ECX plus 4, we have the size, so we are dereferencing that address wherever this TC plus 4, the content is assigned to T1, is the size. And finally we do the write main, which is a WinDBG command. We receive an argument, which is the destination file, the T0 plus 8, which is the MC header, starting address of the MC header of the binary, and then T1, which is the size to be dumped, and that's it. We run it through CDB, and that's it. Is CDB or CVD? Is Windows command line debugger, so CDB. Hopefully. Anyways, we will see it in the lab. That's pretty much it, guys. So let's get to the lab.